Now that we know what the boot process looks like, we're going to look at the system that manages the boot process, known as Upstart. Upstart is fairly new to the Linux world. Most administrators are very familiar with using System 5 style init scripts. We're going to look briefly at those in the next section, but Upstart is the new up-and-coming replacement for init, and it's important to become familiar with it. Some systems are further along in the transition process than others. CentOS runs Upstart, but mainly in a System 5 init compatibility mode, in which Upstart is managing the boot process, but really runs it exactly as if it were a System 5 style. We're going to explore that next, but first we're going to look at a system that has implemented Upstart in some detail, Ubuntu. Thanks to Vagrant, we can really quickly get up and running with an Ubuntu box. I've posted an example here, but you can go and find more boxes at www.vagrantbox.es and experiment for yourself. On my system, I have 2 boxes running. If I can see that with Vagrant status. I have a CentOS box and an Ubuntu box. This lets me log into either one of them at will. I can use Vagrant SSH to bring up the Ubuntu box that I already have prepared. Notice that the command line looks quite a bit different than we've been seeing with the CentOS box. We're still using bash, but the command line has been customized, as has the initial display screen, often called the message of the day, or the etc.motd file. We can see all of the Upstart jobs with the initctl command. If we run sudo initctl list, we see all of the Upstart controlled processes and what their current state is. Don't worry about understanding each one of these right now. The jobs are all kept and controlled in /etc/init. If I list the contents of this directory, you'll see that there's a config file for all of the processes that we saw in the job list when we ran initctl list. Let's look at an example startup file. A good one to use as an example is SSH. As you might already know, SSH, or the secure shell, is a method used to remotely access systems. Vagrant is in fact using SSH in order to log us in from our terminal system into the running Linux box. So if I cat or concatenate the SSH conf output to the screen, you'll see that it's a fairly short script that shows how to start the OpenSSH server. Let's look at a couple of the sections in the script. We have a description indicating what service this is. We show what run levels it starts and stops on. As you recall from our run level screen, levels 2 through 5 are all multi-user, fairly similar run levels. That's all of the run levels we're starting it on. Respawn tells us that if this process dies, we want to start it back up. Remember that oftentimes you're managing systems that are not physically proximate to you. They may be in a different state or a different country entirely. If SSH is your only method to access the system, you won't be able to manage it if SSH goes down. So this line tells it to start up if it stops for some reason. Next, we have the pre-start script. This is doing a few things to test if SSH should be running. It's checking to make sure that the executable that runs SSH, called sshd, is on the system. That's what the test command does. It's then testing whether we shouldn't start SSH. This is an Ubuntu customization. We do a couple of other steps in the pre-start script. But the real important bit is right at the very end, where we're just saying exec sshd -d. That's telling the SSH server process to start as a daemon in the background. So if we look in the process list running psauxw, the command that's starting to become second nature to us, and we search for sshd, we can see an sshd server process running just as we saw in the exact output at the end of that script. Let's look at another example, network interface.conf. This example looks somewhat similar to the SSH config in terms of the sections that are available. We can see that the description is to configure a network device. However, there are some subtle differences. First, under emits. This is an event that Upstart emits when a certain script is finished running. In this case, this particular event is net device up or net device down or static network up. This is a way for different events to communicate with each other. For instance, we don't want to start the SSH process before the network is up. It wouldn't make any sense since having the network up is a dependency for SSH. So this is a way for the networking process to indicate to SSH and other network daemons that the network is available and those processes can now start. Further down in this script, we have what we saw, similar to what we saw in the SSH process. We have some pre-script activities. And then the important line is this exec line, saying bring up the interface if all of this other stuff has already happened. Next, let's take a look at how we control the initctl processes. So again, if I type sudo initctl list, I see all of the running processes. And let's look just for the TTY processes. TTY processes are the terminal processes. If you're sitting physically in front of a Linux computer, you can type in Alt and F1, F2, all the way through F6 on the command line in order to access multiple terminals onto that Linux box. Of course, this doesn't work in a virtual machine like we're in now. It only works if you have a keyboard attached to a physical console. So we don't really need all of these terminal processes running. We can start and stop them with initctl. We can say sudo initctl stop tty6. Now if we check our list again for the TTY processes, we can see that 5 of the 6 are start running just as they were before. It even tells us the process ID for each of them. And then TTY6 is stopped. So if we were now sitting in front of a Linux terminal and we pressed Alt F6, nothing would happen. It would no longer work. In order to start it back up again, I can use my up arrow shortcut to get to the history, and I can change stop to start, and it starts it again. So that's what Upstart looks like on Ubuntu. Let's look at how CentOS has run Upstart. We can run vagrant status to see our boxes. We want to access the CentOS box, so we type vagrant SSH to our CentOS box. Now if we run sudo initctl list, there are far fewer processes running under CentOS's implementation of Upstart than under Ubuntu's. Remember, CentOS still has just implemented Upstart in a very simple form that mostly maintains System 5 init capabilities. If we change directory to etc init, where all of those config files live, there are also far fewer config files. The TTY process is actually very similar. It's saying we don't want all of the TTYs running in any mode except the multi-user modes, which are 2 through 5. It uses exec to spawn each TTY process. That's the essence of what this script does. But the important one for the CentOS system is the rc.conf. This is what maintains compatibility with the System 5 style init. So all this does really, you can see right at the end, is it executes this script, etc rc.d rc. So let's take a quick look at that script. Whoa, there's a lot of stuff here. We don't need to go through all of this in detail. But let's look at the very end at least, because that's where the interesting stuff happens. Right where this comment is that says, now we run the start scripts. So this is going to run through each of the System 5 style startup scripts one at a time and execute them.